Balance a pencil on its tip and wait for it to fall over. Great! You've witnessed spontaneous symmetry breaking, first discussed in a subatomic context by Yoichiro Nambu in 1960. At its simplest, spontaneous symmetry breaking is kind of obvious. In the case of the pencil, if you rotated it by any angle, the system is unchanged. In this way, the physics of the system has rotational symmetry. And despite this, the smallest perturbation will cause the pencil to fall down, and it can't fall down in a way that preserves the rotational symmetry. As such, the symmetry is broken spontaneously. The trouble with this description is that the perturbation is really caused by tiny asymmetries of the system. Perhaps one direction is singled out by a slight breeze, or the tip of the pencil isn't perfectly symmetrical, but is chipped ever so slightly. But this isn't the case in the quantum world. There, a perfect symmetry can still spontaneously break. It just doesn't break in an intuitive way. In the quantum case, depending on which interpretation you take, the symmetry is spontaneously broken when the position of the pencil is measured. Each direction the pencil could have fallen is equally likely, but a measurement collapses the wave function to just a single direction. Fundamentally, this is uncaused. In other interpretations, all directions are realized equally, and we're just entangled with one of them. Regardless of how or which direction the pencil falls, though, in particle physics applications of this concept, like the Higgs mechanism, which gives rise to the mass of fundamental particles, the physics is completely unaffected by which direction the pencil fell. Only the fact that it fell at all in some direction matters. Just as an aside, in condensed matter settings, the direction of the pencil actually does matter, but is determined by thermal fluctuations rather than by quantum measurement. An example of this is spontaneous magnetization. So every time you knock a pencil over, you're sustaining a 60-year-old legacy of particle physicists.